Good morning, Algebra peeps. This is your Monday, May 18th video. This is our last week of new material. We will have no more new material after this week. In fact, we're not allowed to assign any new work after the 20th, Wednesday. So we're going to do a real quick section here. Today, you do not have to do Alex. All right, you're not going to have time to finish Alex. So yeah, no more Alex. We're done with that. Today I want you to watch this video, and the 7-4 practice will go live on Edgelastic today. It's already live because it would have started at like 3 a.m. So you will have Monday and Tuesday to work on the practice assignment, 10 questions, and then you will have to move my thing here over here. Then on Wednesday there will be a 10-question quiz. Same type of questions, same material. All online work is due by May 26th at 3 p.m. We have grades due on the 27th, so I'll need to have everything turned in by the 26th at 3 so I can start recording everything and getting it all in Progress Book. I tried to do a national day, but it kind of bombed. Today's National HIV Vaccine Awareness Day, National Visit Your Relatives Day. Probably should do that. National No Dirty Dishes Day. Whew, there's a winner. And National Cheese Souffle Day. I only ever had one good cheese souffle, and it was on a cruise ship, so that's probably not happening either. I do have a couple of Pinterest posts. When you find out your daily lifestyle is actually called quarantine. And side effect of quarantine, it's really hard to end phone calls. Twice today, I almost said, okay, I have to run, before realizing there's nowhere to run to. Okay, so it's only fitting that our very last section. Oh, good. Thanks, Alexa. Here, she's going on. It's very fitting that our last section in... I'm going to unplug you. Yeah. Our last section has probably got the longest name of any section we've had so far. Solving systems of equations by elimination using multiplication. Fitting. Just to kind of look back, our first section, when we first started solving systems of equations, we solved them by graphing using Desmos pretty much. We would put the two equations in Desmos, and then we would locate the point of intersection. That was the solution. If the lines were parallel, they had no solution. And if the lines were the same line, then they had infinite solutions. Then the next section was solving systems by substitution. That was where we were able to solve for one variable and substitute its equivalent in and solve. All right. Well, this is section 7-4, where we're solving systems using elimination, but instead of adding and subtracting like we did last week, this week we're multiplying. Let me show you what I mean. I have examples. Always, never disappoint you there, huh? Always have examples. Okay, now I'll move the picture up here. All right, so let me switch over to pen here. Okay, so I had to go get the pen. I couldn't find it. All right, I apologize in advance if you hear a lawnmower. My husband's mowing the grass. Now that he's retired, that's his only real job, and he takes that all super seriously. If the grass grows this much, he's out there mowing it. Okay, so here we have our first two equations. All right, our goal is to get either the x or the y terms to be exact opposites so we can add the two equations together and get one variable to drop out. Okay, looking at this equation, we actually have a couple of choices. If I were to multiply the top equation by -3, this would make, hey, what happened? Where'd it go? Okay, if I were to multiply the top one by -3, that would make this top term here positive 3x, and then I could add the two equations together and get rid of x. My other option would be to multiply the bottom equation by 2. If I multiply the bottom equation by 2, this would be -20y, and this will be positive 20y, and those will drop out. All right, I'm going to always pick the easier one of the two. I'm going to multiply the bottom equation by positive 2. All right, positive 2 times negative 3x is negative 6x. Positive 2 times negative 10y will be negative 20y. And positive 2 times 25 is 50. All right, so now this equation is gone here. This one's no longer here. It has been replaced by this one. I'm going to add this bottom equation to the top equation. Negative x plus negative 6x is negative 7x. Positive 20y and negative 20y drop out. That was what we planned. And on the right-hand side, I have 50 minus 15 gives me 35. Now, to get x by itself, I just have to divide both sides by negative 7. And that gives me x equals negative 5. Then I substitute negative 5 in for x in one of the equations. It's 20y equals negative 15, like we've always done. The opposite of negative 5 is positive 5. All right, and then we would subtract 5 from both sides to get y by itself. That gives us 20y equals negative 20. And I'm sure by now you've all figured out y is negative 1. All right, negative 1. So my solution is write the x term first, negative 5, the y term second, and type that into EdgeElastic. Now I know last week I was using multiple choice responses so that we could have infinite and no solutions. I'm just done with those. I'm not going to put any of those in this section. I think you know true means infinite and false means no solutions. So we're going back to, you have to type in the coordinate point, okay? No spaces, make sure you're including parentheses and a comma. Okay. Let's look at another example. I love doing math examples, it's super fun. All right, in this one, I'm looking at my terms. Now, to get the x's to drop out, I would actually have to multiply both equations. And next year or the year after in Algebra 2, you'll probably be faced with ones like that. In fact, if we weren't doing this from home, I would have shown you some like that. I'm trying to make it shorter since you're working from home. But there will be times when you would have to multiply both equations to get the terms to match up. In this section, I'm only going to have you have to multiply one equation. So this isn't it. Let's look at the y's. How could we get these two y terms to be absolute opposites? Well, if this negative 3y was a negative 9y, it would cancel out with a positive 9y. How do I get negative 3y to be negative 9y? I multiply it by 3. So I will have to multiply the entire equation by 3, right? 3 times 2x is 6x. 3 times negative 3y is negative 9y. And 3 times negative 3 is negative 9. Now the top equation is gone, and I'm just adding these two equations together. I've got it all set up so the y's will drop out. Negative 3x and positive 6x gives me positive 3x. Our 9's drop out, and 9 minus 9 is 0. All right, which means x has to be 0. Substituting 0 for x into one of these equations, I'll use the bottom equation. Negative 3 times 0 is 0, so I know 9y is 9, which means y has to be 1. So the answer you would type into EdgeElastic is 0, 1 with your parentheses. So all these problems in this section are going to be like this. You're going to need to multiply one of the equations by some number to get terms to drop out. Okay. Now, looking at this one, we actually have two choices here. We could do two different things. We could multiply the bottom equation by negative 2. If we did that, this 5x would be negative 10x and would drop out. The other solution would be to multiply the bottom equation by negative 9. If we multiply this by negative 9, this y would become negative 9y, and it would cancel out with the positive 9y. I don't know about you, but I prefer to multiply by 2 than 9. So let's go ahead and multiply negative 2 with the bottom equation. Negative 2 times 5x is negative 10x, just what I wanted. Negative 2 times positive y is negative 2y. And negative 2 times 3 is negative 6. So this equation's gone, right? I'm combining the top equation with the bottom equation. Never did get the hang of this writing board. The 10x's cancel out. That's positive 10x, negative 10x. Those are gone. I add positive 9y and negative 2y. That gives me a positive 7y. And 27 minus 6 is 21. Divide both sides by 7 to get y by itself, and I know y is 3. Substituting 3 for y in one of the equations. I know what x has to be. I bet you do too. You guys were always really sharp. 5x equals 0, and if 5x is 0, x has to be 0. So make sure you put your x variable first, your x coordinate first, 0, y coordinate second, no spaces with parentheses. Righty? Now, I want you to try these two. Okay? These are two for you to attempt. Ideally, I would like you to pause the video now and do these problems, and then when you come off of pause, I'll have the answers for you, or I'll work them out for you. Okay? So if you're following directions and playing along, go ahead and pause the video now. If you're not following directions and following along, I'll go ahead and do them. Looking at the first equation, how do I get something to drop out? The 5 and the 9, I would have to multiply both equations. I don't want to do that. So I notice that if I multiply this top equation by negative 2, I'm going to write it over here for more room, I will have a negative 6x, and that will cancel the positive 6x. So let's do it. Negative 2 times 3x is negative 6x. Negative 2 times negative 5 is positive 10y. And negative 2 times 3 is negative 6. So this equation's gone. 6x minus 6x, those cancel out. Negative 9y, positive 10y gives me positive 1y. And 6 minus 6 is 0. So in this case, y was 0. Plugging 0 in for y in one of the equations gives me 3x minus 5 times 0 equals 3. 5 times 0 is nothing, so 3x equals 3, and so I know x is 1. So my answer to the first one is 1, 0. How'd you do on that? Right. Over here, let me change my ink color. There we go. Over here, I'm not going to be able to do anything with the 5 and the 7, but boy, the 15 and the 5 are just begging to be done. So we're going to somehow make this negative 5 be a positive 15. Well, what do I multiply negative 5 to make it positive 15? You guessed it, negative 3. Okay. Negative 3 times 7x is negative 21x. Negative 3 times negative 5 is positive 15y. And negative 3 times negative 28, I have this written down somewhere, is 84. I knew I couldn't do that one in my head. So now this middle equation is gone, and I'm adding this equation with this equation. Well, negative 5x and negative 21x is negative 26x. Our y's drop out, and 84 plus 20 is 104. Then if I divide both sides by negative 26, I get x equals negative 4. Substituting negative 4 in one of the equations, let's see, we'll go with 7x minus 5 y equals negative 28. Substitute negative 4 in here, that gives me negative 28 minus 5y equals negative 28. And if I add 28 to both sides, I'm getting kind of low. How low can you get? I get negative 5y equals 0. So we know that y has to be 0. So the solution on this one should have been negative 4, 0. Well, I hope you got this. I hope you understand it, and I hope that it's easy for you. But if it's not, you know you can reach out to me anytime. Email. I've given you all my phone number. You can text me. You can call me. I'll be there to help you. Anything you need. Okay. So you've got today and tomorrow to work on the practice assignment, and then Wednesday the quiz will be live, and that will be your last assignment from yours truly for this year. Okay. Have a great day.